Okay, thank you, Ron, for joining. I'm probably gonna start today. We have a bit experimental talk with Bill. We're gonna be sharing our experience on one of our clients and kind of reflecting on the takeaways and gotchas we got there. We will be just like a quick teaser. We're gonna be talking about infrastructure. For us, infrastructure, it is everything that makes system work, but it's not a code. So it's some network computation storage, but it's nowadays everything is virtualized for us by cloud providers. So as folks responsible for infrastructure, we manage these resources via some configuration and other different things. Yeah, when we maybe next slide first. So we're going to be talking about a project where we worked with Bill. This project has quite a history. So it was originally, its infrastructure originally was created using only Ansible. We're going to dive deeper what is Ansible, what is Terraform, and all the details around that. But then it was degraded to very manual infrastructure management, and then 8-Lite onboarded, and for several years we were maintaining that project, having in a head that dream that implementing some Terraform, some infrastructure work, we gonna shift this system to the new state. And the state basically is that, yeah, the system is in AWS, and the state which 8-Lite got the system, it has everything runs on a single account with no environment separation. So there is no staging, no development, no production. The changes are undisciplined in the sense that there was no clear CI/CD. So people were just going into machines and doing something. And of course, yeah, there are multiple EC2 instances that are long running, they are mutable, they are running for years. And we want the dream state of this system is just pretty basic, well-architected 3-tier application infrastructure, which gonna solve tons of the problems. So we imagine or implement VPC per environment and immutable short-lived servers. That's basically containerization, which gonna make this system reproducible and rollbackable. That's very, very much high level. So we're gonna be talking first about the tools like Ansible and Terraform in IT asset management history, then go a bit deeper in our case study, talk about the problem of data migrations and the solution we came up with, which is Runbooks, and then summarize our experience. So this is where I give control to Bill. Actually.
Yes, thank you, Sergey. Okay. All right. I'm going to talk about IT asset management history. First, a disclaimer. Well, I guess number one, I promised you won't fall asleep. But yeah, also, we're not historians, and we're not even business process consultants. We're practitioners. You know, we're software engineers. Yeah, we do have a specialization in infrastructure, but yeah, we come at this from a practical perspective. But that being said, we've seen a number of things. So let's talk about our experience and, yeah, the industry that we work in. So in the beginning, we had change management. Change management system can be a lot of things, but at its basic, it's about customers interfacing with system administrators, asking for changes. That system admin recording the requests, tinkering on the systems, and then recording that the work has been done. The tools of the trade especially in smaller organizations can be pretty raw. You have your manual, you have some kind of note-taking device, you might have a screwdriver back in the not so distant past, if you're disassembling a server rack to replace a storage drive or something like that. Eventually you have some evolution, which doesn't really change the system in kind, but just it's just the implementation. You might start to build an internal wiki inside your organization. You might start to share shell scripts in a small team to make routine tasks more consistent and faster. The advantages of this change management approach, sometimes this is called ITIL. I can't remember what the acronym stands for, but at a basic level, you need some kind of tracking about what is happening. The changes that the tracking is attributable to the person who's asking for it, usually have some kind of reason, some purpose behind, business purpose behind that change. And in the moment, the status of those work items is shareable with the people that are requesting it. Challenges, however, with change management was that procedures were very ad hoc. The how of the fix is very often untracked, because the change management system might mostly be about a technical practitioner speaking to a non-technical requester. You're not going to tell them how you created the new RAID array. And then the system described, the system that is being worked on in this change management process is never really described in like a thorough way, at least after its initial creation. You have to kind of look at each of the incremental changes to understand what's going on in this quote unquote legacy system over time. So we evolved in the industry. We had a proliferation of automation tools like Chef, Puppet, and Ansible to deal with some of these challenges. The two of us know Ansible best, partly because it seems to be really the final survivor of this first generation automation tool group. So the beginnings of these tools allow for the beginnings of infrastructure as code. So now possible, we have a source repository of data and code representing our system configuration. So before I was saying that we don't really know what the system is other than the collection of changes that we've made in the past. With Ansible, I can actually look at a directory of files and get a sense, okay, so we have these servers. Those servers are running these particular kinds of services, and those have a variety of configurations. Those make sense. It makes more sense as a what. I understand what the system is by looking at the code. So some generalizations of the difference between these infra as code versus shell scripts is where shell scripts are pretty independent. Infra as code, declarations are more composable. So I can have an Nginx web server configuration sitting alongside an SSHD configuration and a storage array configuration, and those things are just easily composable with infra as code techniques. Shell scripts emphasize how to change things. They're imperative. Infra as code is more declarative. It's an emphasis on what is desired. Shell scripts tend to be designed to be executed once with like a specific before and after state. Infra as code, because of that declarative style, can be executed whenever and just repeated without negative side effects. So yeah, Ansible specifically, talking about the particular model there, Ansible is organized as a set of tasks. And a task is basically a declaration of a desired state. So for example, I have a task here called directory present. I want the directory to be present, and then Ansible goes and makes the syscalls via Python to make that directory present. So it'll check whether the directory is already present with an ls command, and it'll make it'll do a make dir if necessary to get it there. So those declarations, the way that those are composed, though, is a little bit goofy. So I describe this as a declarative and procedural lasagna, because once I declare that this directory is present and that this file should be placed, composing those two things, it's my responsibility as the Ansible code writer to actually create a procedure between these. So I sequence these things, task 1, task 2, and if I get this sequence off, yeah, I'll get nonsensical results. This procedure will fail. The Ansible will fail to execute, because it's actually my responsibility to say, okay, this declaration has to be enforced before this declaration. And it's very meta, where the tasks are organized in roles and the roles are organized in plays, and plays are organized in playbooks. But it's the same idea, where at each level of abstraction, you can say, okay, yes, this role is responsible for, yeah, again, configuring our Nginx web server, sure, but you have to know as the developer that, for example, the distribution package manager needs to be configured before that, or else it's not going to be able to download the Nginx binary. So it's a little bit leaky. It's not 100% declarative. So yeah, that's frustrating. It's a little bit hard to manage those sorts of things. It takes a lot of context. You have to know the Ansible DSL, but you also have to understand the system, and sort of think about a lot of those details as you're working. So we evolved. We wanted to go to more declarative systems. We want immutable declarative infrastructure. We want to say what we want and not how to get there. I don't want to write procedures for Ansible. I just want to write a bigger declaration. And I want an intelligent engine that can evaluate the entirety of my specification and compare it to a current state before it even makes the first change. So an example of this kind of system is Kubernetes, where we write a bunch of manifests about like different services and tasks that we want to run, and then Kubernetes intelligently decides, okay, I'm going to schedule this on this server and another on another, and manage lifecycle for us. We're not going to talk about that in this particular talk. Instead, we'll talk about Terraform, which is another system like that, where we have a template. The template is our specification, our declaration. We inject variables into that template. And when we make a plan, that template is going to be compared against some state in a real system like AWS. And those things are compared. The template plus variables are compared with the state, and it decides, okay, yes, I need to create this new load balancer. I need to tweak this security group. I need to resize this database, whatever the case may be. And once that plan has been derived, usually there's some kind of human, well, not usually, often there's some kind of human check at that point, and then we perform an application which actually is responsible for moving the state along. So the procedures are all done by this template, this Terraform engine. So yeah, advantages over the first gen. If a plan is derived, the operation should succeed. Put a little asterisk there, understanding that anybody that's worked with Terraform for a not insignificant amount of time, you do get runtime errors in Terraform because your Terraform providers are not actually 100% aware of the complexities of the underlying APIs, but there's no reason why they couldn't be designed, they couldn't be enhanced to the point where actually those runtime errors are just exceedingly rare in some future point. The Terraform technology is possible to get there. Another advantage is that specific resources can be defined only in one way, which means that our infra source repositories are more trustworthy. So we can't undo Yeah, for example, that security group configuration from one module to the next, because Terraform has one representation of these resources. There's no procedure that can be contradicted. And finally, because it has this state check before it goes about its business, fewer details can drift from the specifications that we're writing. Disadvantages to the Terraform model is that adding support for new resource types is more involved. That's a limitation that we don't have to worry about with big providers like AWS, but it's something to be aware of. And operators, that's us, lose control over the when and how of changing our state, our system state. So yeah, the when and the how is really what this conversation, this talk is about. Delegating our execution plans to something like Terraform. Yes, it takes away a lot of that responsibility that we were just kind of like just tired of dealing with, of just figuring out these tedious state changes. But sometimes we have certain things that we need to control in the switch from one state to another, that we're also giving up. And so we're going to talk about what are the implications of that. Let's observe a case study. Back to you, Sergey.
All right. Let me quickly switch. Yeah. So now putting it slowly into perspective of the system we needed to migrate and modify. And during the migration of the system, we made a bunch of mistakes on which we are reflecting in this talk as well. So since 8light onboarded on the project, there was this dream of sort of waterfall switch to the new infrastructure. So we have like a very tangled old state, and with some effort, we get to something absolutely new. And when I was onboarded on the project, I was onboarded only for a few months when this plan was ongoing, and I needed to basically build this right part of the system, and then somehow migrate. But we didn't have enough inputs to understand the scale of the migration issue. And at that same time, I was also making my AWS certification. So I thought, why don't we use some out-of-the-box AWS services? And that was also a mistake, because no one gonna do this work for you. So I started with the fun part, building nice, clean infrastructure apart from the existing one. And then we started to come up with a migration plan. And the more we were diving deeper into it, the more detailed it became, until it couldn't fit into one slide. And then we started to see that many things are coupled to each other, like load balancing and containerization of applications. Huge work was made by 8lighters before me and Bill to containerize the solution, but the legacy even of a simple, relatively small 3-tier application is huge. And Bill onboarded, and we realized that we need to give up this like waterfall-like plan and start building migration part step by step. And our area of choice was database first. So the idea was to narrow down the migration. So we had two infrastructures running next to each other, and we started to build a bridge between old instances that are running code and new database. And the migration was a plan to redirect those instances on production to production instances of the new database. And of course, migrate all data to the new database. So the problem of data migration was the major problems we faced in that narrowed case. We needed to prevent data loss, we need to minimize downtime, and allow safe rollbacks. And the only good thing we could come up with, we started to write down everything we know what we need to do this switch. And yeah, it's basically a runbook. It's basically a document. This is a table of contents, content of that document, having pretty detailed steps that we should do in order to do the migration. It is organized in a way of this big dream of migrating entire system at once, but we're filling out those sections as we progress. And the migration was actually first do things on staging, writing down the document, and then execute these steps on production, having quite a flawless switches. So conceptually, this runbook consists of several layers. There are parts of Terraform code that are managing infrastructure. So the whole point of migration is to move all the management of the resources of this infrastructure to Terraform state, because the old state is unknown. So things are created manually, and what is their state is unclear. So sometimes those resources can be written to the new Terraform state via Terraform. Sometimes there should be some more manual actions and reuse of existing Ansible scripts or writing more Ansible scripts. So it's like layers of things that are needed. And that is actually the game day Gantt chart diagram that we when we were actually executing the database integration. Bill, would you like to give more details here?
Yeah, sure. Yeah. So a few slides back, you saw our sort of master runbook, which is actually a number of runbooks for different components that we switched over. But this Gantt chart is for kind of our most complex, highest risk transition, which was moving our relational database from one virtual network to another. And so we really wanted to make sure that we had a really firm plan for the day of. So that included creating a Gantt chart in this great package called mermaid.js, and continually refining it at the same time that we were refining our runbook. And something that you'll note, if you can read this, but if it's okay if you can't either, is that the steps in here, there's different steps in here, some of which are, and pay no attention to the specific arrows because those don't necessarily fully apply, but some of them are utilizing Terraform, the framework, to either plan, to verify that the state is the way that it should be before we begin the system state, so that we don't make the wrong kinds of shifts, and then applying a new template that we had tested and prepared for a specific point in the transition. We had Ansible scripts in here for operations that just took a lot of different steps. Remember, Ansible is basically just a scripting language, and was able to reduce the amount of time that we spent on particular steps. And then finally, some things had to stay manual, like we had actual smoke testing of the website on the new database resource. And so like those things needed to be, paused for not for a specific time, but until they were ready. And so just having this in place and putting it into real time, like you might see that we even had our daily stand-up in this schedule. It just helped us circulate what's going on, what everybody's role is, and just be ready for the day.
Yeah, it was like clockwork. So yeah, one more conceptual thing about the Runbook. Yeah, it still has the stages of planning, then had a hand effort of execution, and we are getting to desired state. It's kind of what we want from automated systems, and probably the more migrations we do, we can automate some steps. But yeah, it's still list of instructions, but it's also including human actions, not only machine in this migration. And writing down all the things that we need to do finally actually allowed us to build a high-level map of what migration evolves. So this is actually our quest, the map of our journey from one system to another. And we are still continuing on that. We migrated all the databases and now part of the ALD, but there are still many things to wrap up. So, but again, writing those things down can give at least a feeling of the scope of these endless surprises that are popping up from legacy systems. Yeah, and yeah, I think I will give back to Bill completely here.
Yeah. So let me pull up that same slide deck, but okay. Yeah. So how did it go? We think it went pretty well. You know, we were nervous about our downtime window. We wanted to make sure that it was no longer than it had to be, but also that we were confident about the transition before we moved back, before we went live, because you know, when you're dealing with a you know, with a read-write database, rollback is either very slow, or if you make it fast, basically you can have fast rollback until you start writing again, and then rollback gets complicated. And so we had to balance a lot of considerations here, and we were successful. And yeah, you know, maybe we were just lucky, but I think we were also pretty prepared. So yeah, some conclusions that we drew from the experience. You know, again, we talked in the early part of this presentation that we had this Ansible system that had sort of fallen into some disrepair over time, and we had a concept of a great leap to a new infrastructure that would just get us to someplace happy. But we realized there's a big missing link here in terms of the how of getting from one system to the next, because these are production systems. They're not, this is not greenfield. And we had to fill that in with a combination of methods. Our Runbook approach takes things from all of the different stages of the IT asset management history that I was presenting before, where we have those manual steps, we have the scripting, you know, idempotent when possible, rerunnable, and we have the Terraform declarations as well. Yeah, so the new vision includes elements that didn't require this kind of stuff. There's immutable, short-lived, replicable resources that are very straightforward to replace. But then there were also the mutable, long-lived, and singular ones. So with those immutable, short-lived, replicable resources, like, for example, an application container, stateless application container, we're able to just spawn a new resource alongside the old one, move our router to point at the new resource, and then, you know, at our own leisure, drop the old resource. So advantage of that approach is that there's zero downtime required at any point in that. We can pause the process at every step along the way. We can break for the weekend, on step, 1, 2, or 3. It doesn't really matter. And because of that, also we can go through our software development lifecycle, where we submit a merge request, test it in a lower environment, get code review, et cetera, and so forth. That's a great way of developing things. However, it's not always possible. With the relational database transition that we used as an example for this, we had mutable long-lived singular resources. In that situation, in order to have data integrity, we have to cut off access as the first step of our transition. We have to replace the old resource fully when the service is down, and so that might require a lot of passing a lot of data over the network wire, and then we have to reestablish service to that new resource, and something that's not visualized here is that then we have to do some kind of testing before we make the router available to upstream consumers, because we just need to verify that this new resource is suitable to the system. All of that stuff has to happen during downtime. So the service is halted for the entire process. Every step must be executed as quickly as possible. Every step must be planned in advance, and rollback is hard. Those are the constraints with these hard things. So again, the way that we dealt with this is with this layered approach. This is kind of the frame, which I probably should have introduced early on. It's similar to functional programming, where we have the functional core imperative shell. I guess it's not really even an analogy. It's just actually just an application to infrastructure. Similarly, we have a declarative core of our Terraform state and template files. We have some procedural glue in the form of Ansible and other scripts to get us from one state to the next. And then we have a manual shell of like actual steps that operators or even like product people have to perform to verify that the system does what we want it to. So basically, yeah, this is an encouragement to basically take advantage of all of the learnings that we had at all the different stages of our IT journey. It's true that we like these technologies in the core. We like to put more and more into these, but when your needs are not satisfied with them, basically don't just improvise. Make a plan that takes advantage of those solutions that we've honed over decades in the industry. That's our talk.